surprised you didn't run out of smart word writing all that down.
Oh, just gonna do some fancy copying and pasting on that one.
Did you rewrite all your goals?
Uh-huh.
Are you kidding me? I already wrote something down on the wrong thing.
Holly and Tyler, while I'm thinking about it, next Tuesday, this coming Tuesday, y'all are taking the PSAT, it's not, you're not taking it that day, but that day, she's calling people out to fill out the forms.
Yeah.
But in this class, we're doing that's the day for the math ACT Aspire interim. So I went and talked to Miss Simmons yesterday, and she's just gonna call y'all out at another time, so don't panic about it. She knows, and she'll get y'all taken care of.
Thank you.
Y'all 10th graders got that all week next week, those interims next week.
What you say, they have the interim this week, so they taking something in here?
Tuesday,
What would I be doing?
nothing.
Killing?
Mhm.
Sweet.
Lucky. Are we gonna be trying to piece paper?
Can I have all the seniors that dress up for Spirit Week come to Lottie?
No.
The only thing the juniors do for their testing is they take a ACT during the spring. So one day during the spring, we're gonna do that.
And I assume we'll just keep on working then?
Probably, since it'll just be one, 4 and 1 is different than 1 and 4.
It'd be nice if you kept on teaching. We'd get some examples.
Alright, we'll just give you a few more minutes and then I'll roll it up, cause there's some more underneath it. where are you on, Christian?
Second from the bottom.
So that's the root, so it's like a square root, but it's got a little out in it. The root, and then b to the is equal to b to the over n. So it's like a division slash, but it would be a fraction.
There's a lot of power.
Yep, there are.
Are there just those four, or are there more?
No, there's no. Oh,
Oh,
more
power rules?
power.
I think I see a line. I think there's just four power rules.
Let's see, that's some of not losing one. Okay, that picks up negative and 0.
Is that third power rule? Is that m square root bn?
The is in the root spot, so you agree that the root of be the m.
M.
Yeah.
Are we gonna have to memorize all these?
You're gonna use them enough, you'll become familiar with them. Everybody at least passed the quotient?
The zero rule is real easy.
Yep, anything to the zero is one.
Heck, done it, there's multiple zeros.
You should do all zero.
I agree with that.
Or all one.
That's pretty easy.
You lost me with power.
I got a little chant for power rules. You remember it?
Is it gonna be quadratic all over
It's
again?
just a little chant, just 3 words.
Power.
Power over root, power over root, power over root. You'll see when we use it, I'll explain it when we use it.
Oh, I think that's
I need all the juniors dressed up for Spirit Week to come to the high school lobby.
Zach, are you going? Good thing.
For the juniors,
I didn't dress up today.
I look like a junior.
Wait, is that supposed to be like 1 over -1? And in even and odd on minus 1?
No, well, all that's telling you is that if the power is an even number, your answer will be positive. If the power is an odd number, your answer will be negative. Say that again?
Is there one more down there?
No, that's all.
I don't understand how the negative ones work yet.
It's okay. Just writing the rules down, we're gonna learn to use them. Alright, come on over here and work your else, get you rocking.
We should have nap time in here.
Oh, whatever.
That's what the classes for.
We'll get through next time.
Okay, so we're just gonna start working some examples and try to apply those rules to them as we go. So here I have a problem that says -4 times 2 to the 5th, all squared. So what we know about how this is written is that this 5th power is only on the 2, but this 2nd power is outside that whole parentheses. Okay, so that means that a 2nd power outside the whole parentheses has to impact everything up there. So we would say, I bet that looks kind of like the power of a product. So I'm gonna have to do -4 squared, and I'm gonna also have to do 2 to the 5th squared, right? And we write down a property that's, if the power was outside, you have to give it to everything, right? Okay, so how would we simplify that up now? What's -4 squared? 16, very good. And what about 2 to the 5th to the 2nd? What do you do with that piece?
You do-
Multiply them.
Okay,
You do
good.
2D.
I call that, I don't remember exactly what you wrote down, but I call that the power to a power. Did you write down something that said power to a power?
Power rule?
I don't remember.
It
What
was
they
the-
call
It was the
it?
first one on power rule.
Yes, power rules, and I just say that's power to a power, so those multiply, so
Wait, did
this,
it have like individual names on it?
no. So this would be the same as 2 to the 10th. So now that's actually, some people will be like, well, that's not very big, but that's actually a pretty big number, cause that means 2 times 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 2.
That was,
Okay, so I'm gonna old school it.
We did
To
that
do
before.
that on your calculator,
and
your power button is that one that looks like a teepee, so you would do that. But I'm gonna write 10 of them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2,
16.
512, times 2, 1024. Right,
Good job.
okay, so I'm still not done, right? Now my last problem is gonna be to find what 16 times 1024 is. And y'all got calculators to do this, I'm just old schooling right now. 12, 13, 14, 0, 1, 0, 4, 2, 0, 1, 4, 8, 2, 7, 1. Oh, I got it wrong. 16,384 is what I should have got, so according to 16,384, according to Tyler's calculator, what did I do wrong though? 6 and 4, 4 carry my 2, there's 12, make that 13, 14, carry my 1, that's 0, 6 and 0, 0, so that should be a 1 there, and that should be a 6 there, so that would make it work right. That would be the 16,384. Alright, now, as we do this, and if you need to either pull your calculator up on your Chromebook like Holly did, or you got yours out like Tyler does, you can type that into the calculator exactly like it is and get the same right answer. But what's gonna happen is you're gonna see, like on those examples you copied down, sometimes there's gonna be variables in there, and you can't type the variable in your calculator, so you'll have to know what steps to use. Okay?
Or you could just, if you figure out what the variable is, you can just store it for x.
Yeah, but we're not gonna be solving on right now, it's just
Yeah.
gonna be the simplifying, so. Alright, let's look at another one. I got 11 to the 5th over 11 to the 8th, all to the -1. Now, when we're using these exponent properties, like this one involves more than one property, like the last one did as well. Sometimes I might start with one property and Christian might start with another property, but we both still get the same answer. So you don't always have to start exactly the same thing. What I would do on this one first is mess with that -1 power. And your negative exponent power tells you, I don't know if I'm using the same letters as you wrote down, but it tells you if you have a negative exponent, you put it on bottom and make it positive, right? You see you wrote down something similar to that, a negative exponent puts it on bottom, makes it positive. But here, the negative exponent has already got a top and a bottom. So I can't just put a top and a bottom all on bottom. So what do you think would happen when you already have a numerator and a denominator?
You flip
Very good, you just are gonna take the reciprocal. So this is gonna be the same as 11 to the 8th over 11 to the 5th. So just like put it in the opposite spot like your exponent rule says. Now, that would be positive, just like your exponent rule says, it turns it to a positive. So do I need to put a first power out there?
No.
What's anything to the first power?
Yeah.
Itself, so we can put the first power, but we don't have to. Okay, but I'm not done with this yet. Now I've got some division going on, and so you wrote down something about a quotient power. When you got the same base like we do, 11 and 11, what did the quotient rule say to do with those exponents? subtract them. So that's gonna be the same as 11 to the third. And now you can actually figure out what 11 times 11 times 11 is.
Whew, that's a lot.
What is it?
1331.
1331, 1,331? Is that what you got, Holly?
Cause I was like, you know what, I'm gonna do this in my head, 11 times 11. that's
Yeah, I had 121, but I was,
Yeah, I had 121, but 121 times 121 is a big number.
okay, so, and again, you could, as long as you're careful, your calculator can handle all of that. But like I said, we're fixing to see variables, and you can't do that in your calculator. So let's go ahead and look at some variable ones. Let's say I've got b to the negative fourth, b to the sixth, b to the seventh, and my directions say to simplify. Now this is an easy one for us here because our base number, that's what the big number is called, my base, it's b in all of them. So that makes it easier for you. So there's no sign between those b's, which means multiply. So you're looking at the property that when we multiply with the same base, what happens to the exponents?
Yeah.
Add, very good. So this is gonna be b to the negative fourth plus 6 plus 7. So that would be b to the ninth, and that's it.
We should fill in.
Alright, so I got r to the negative second over s to the third, all to the negative third. Alright, so what I would do first here, since that negative exponent is on the whole thing, I would take care of it first. And your rule you wrote down was about a -1 exponent. But anytime you have a negative exponent, you're gonna put it on the bottom and make it positive. So you're gonna flip it and make it positive. So the reason flipping it is because we got a numerator and a denominator. So let's flip just the meat, just the stuff, the quantity, the stuff inside the parentheses. So we'd be looking at s to the third
Oh, that's an S, I thought it was a 5.
over r to the -2, all to the third. Now, let's talk about what Holly just said. That r on the bottom is a negative. So should it turn positive at any point?
Really good, but it just
No.
make it complicated.
It might have to at some point, right? So let's just go ahead and simplify, keep simplifying out here and see what happens. This would be, if I distribute that 3 now, I've got a 3 times 3 and a -2 times 3. You multiply on that, very good. Okay, now I'm to my dilemma. I've got a negative exponent still, and we're not allowed to leave a negative exponent in our answer. The directions will always say, make sure your exponents are greater than 0. So I've got to do something to make this a positive. So our rule, we said, you put it under 1 and make it a positive, but it's already on bottom. So where do you think we're going to put it? On the top. So you're just putting it in the opposite spot. So we're going to make that a +6 and move it to the top. So we're going to have s to the 9th times r to the +6, and that's it. That is it. That is it.
I need all the sophomores dressed up for Spirit Week to come to the high school lobby.
Lobby. Lobby. Go ahead. You going, Holly?
No,
Look at Snazzy in your sweater over there.
I don't want to go.
Okay.
I'll feel that.
All right, let's try another one. Get Hayden on board here. Let's say we got x to the negative third, y to the third, all squared, over x to the fifth, y to the sixth. Okay, so your dilemma on these, most every year, I mean, yours might not be, most every year when we start doing this with the students, the thing they struggle with the most is just knowing where to start. So what do you guess here? What could, the directions just say simplify, so what do you think we could start doing to simplify?
Would it be the quotient rule?
Not yet. Okay, good. Generally speaking, when you've got something outside the parentheses, you need to,
Distribute it.
good. So that's gonna, whoops, I pushed the button, I think. That's gonna mean I'm gonna raise that to the second power and that to the second power, so those get multiplied. So that would be x to the negative sixth, y to the sixth, over x to the fifth, y to the sixth. Okay, so now I'd be ready for what Tyler recommended, the quotient rule. And what you gotta be careful with on the quotient rule is to make sure you're doing the ones with the same base. So I'm gonna look at my x's separately from my y's, cause they're different bases, right? So quotient rule subtracts, so I've got x to the negative 6 minus 5. And then I've got a y to the 6 minus 6. Now, you don't have to write that step out, but since this is our first day with exponents, I'm just trying to show you what's going on. So on the x, when you do negative 6 minus 5, that gets me negative 11. And on the y, 6 minus 6 is 0. So it's not done yet. We still have two properties that I see there. I've got the negative exponent property and I've got the 0 property. So what does the negative exponent property say to do with this?
Put it on.
Put it on bottom and make it positive. And what's y to the 0?
It's 1.
1. Anything to the 0 power is 1. So I already got a 1 up here. If I put another 1 up there, that just means 1 times 1. So that's my final answer. What you think about that?
Seems complicated at first, but it's not as complicated as I thought it.
It's not bad. Let me give you one to try by yourself. We're gonna have an assignment over it tomorrow, so we'll get a lot more practice with it. But let me give you one to try by yourself.
We weren't supposed to do anything yesterday.
No, didn't have anything.
And for coding as well.
Correct.
Thought so. I had an easy day yesterday. All I had to do was my first period.
To teachers and students, if you have your flu form filled out, please bring it to the office at this time.
Alright, I'm gonna be quiet while you give that one a whirl. Okay, I think early on, everybody should have gotten something over here on my far right. I'm not done yet, but that's what you would get when you distributed that power 3. Okay, everybody okay on that? So now, what, property are you gonna be dealing with?
Quotient.
Quotient, so I'm gonna have an x, quotient, division, you subtract your exponents. So I'm gonna have those two little problems to figure out. That 12 minus 9 gets me an x to the third, and that negative 6 minus 18, 6, that negative 24. Okay, so am I good?
No,
Nope, can't leave a negative exponent.
need to put it on the bottom.
So am I gonna put the whole thing, the x and the y on the bottom?
No,
No, just the one with the negative, so x will get to stay on top, the y goes on bottom and becomes positive.
It's a big power, 24.
Yeah, that is a pretty big power, a lot of stuff on that. Now, one of the things, and it was what I was talking to Christian about before we started, that power over root thing, that does not come up in this lesson, but we will be seeing it in this unit. So some of that stuff that we won't see today or tomorrow, we still will get to before it's over with. You just won't have to write them all down again. Now, what this unit that we're starting is gonna be about, last unit was all quadratics. So this unit is just gonna be general polynomial functions. So it could, a quadratic is a polynomial, so it could be something to the second power, but it also could be cubic to the third power, or quartic to the fourth power. So our functions are gonna start getting bigger, which means the graphs do more interesting things. That's what we're gonna start seeing in this unit, which is why we gotta practice with simplifying exponents, because we might have a function that's got some crazy exponents in it. Okay? Alright, so tomorrow we'll do some more of this. I'll have you an assignment to practice on it after we do a couple of review ones to get started. And then next week we'll start getting into the graphs of some of these. Cool looking graphs, some of them will make like roller coasters and stuff. Alright?
You gonna make a game table?
Yes, sir, I already got